atmosphere and then affect these magnetic field lines. And ideally, you want to affect those magnetic field lines at the closest place to which they intersect the planet, which happens to be at the poles. And in the case of where Alaska sits on a map, very near the poles, the furthest northern territory in the United States, where you could locate a facility on U.S. territory that you could inject energy directly into the magnetic field lines of the Earth. We're going to be talking about an area above the Earth's surface, about 30 miles above the Earth's surface, moving out several hundred miles beyond that, the ionosphere. It's a highly charged area. It filters out cosmic radiation, various particle streams that without it would make life impossible on the planet. Now, one of the ideas behind HAARP, which is an array or field of antenna here in Alaska, 180 antenna in the array today. It fires or concentrates, focuses radio frequency energy that it literally sends up into a relatively narrow beam, affecting the magnetic field lines in one instance where the energy is normally naturally flowing from the South Pole, coming up, arcing high above the equator, then coming back into the North Pole, with the energy flowing from south to north. What happens is those magnetic field lines act as waveguides, so you can pump energy out of HAARP, focus it on those magnetic field lines, and then it screws itself. You would be able to see it with like a corkscrewing motion, where the energy is actually moving now from north to south, using the magnetic field lines as a waveguide. Now, what would that do, essentially? If you had, for instance, an intercontinental ballistic missile that gets fired from China to the U.S., and it traverses those magnetic field lines with those charged particles racing along them, using them as waveguides, and create a virtual shield around the planet, so any of those incoming objects, intercontinental ballistic missiles, any satellites that happen to traverse those areas, or any other electronically sensitive equipment would be destroyed almost instantly. And so when you think about HAARP, there's a couple of ways to look at it. One is manipulation of those field lines, those magnetic field lines, which actually have been mapped. And if you look at some of the ways those are mapped is barium particles are injected into the upper atmosphere and lower ionosphere using barium-laden rockets. But those create, when you inject radio frequency energy, as air glow, where you get this sort of light-up effect. So you can actually see this corkscrewing motion around those magnetic field lines and serving as waveguides. In fact, they did that test a number of years ago in Alaska, and they do these from time to time, just more or less illustrate what they think theoretically should happen is actually happening in place and at the time of the experiments. Now, HAARP as an array of antenna can be focused and concentrated. You got to think about this in a much different way than normally how radio frequency energy behaves. If you think about a radio broadcast antenna, broadcasting radio frequency energy, that energy dissipates or spreads out very rapidly from the point of broadcast, the antenna, out into the atmosphere. And the further away you get, the less dense, the less concentrated is that radio frequency energy, which is why radio stations eventually fade out over distance. On the other hand, what HAARP does is by firing this array or field of antennas, you imagine firing them in such a way as to create kind of a corkscrewing motion, a cyclotron resonance is what it's called, where that energy is then focused to a smaller and smaller area, and as it hits the ionosphere, it becomes concentrated. And think about that in the same way as light coming off of a laser versus light coming off of a flashlight. When you think about HAARP, think about it as a mechanism on the ground that's designed to interact directly or to plug into those magnetic field lines and actually then use the environment itself as part of the machine on the ground. And think about it in this sense. Think about that machine on the ground, this field of antenna broadcasting radio frequency as a primer, the small amount of energy, because the big energy is contained in the natural environment. The idea is if we understand enough about how these mechanisms work, then we can trigger various cascading effects where it sort of builds on the energy that's naturally in place. And so when you think about HAARP, not just in the effect of magnetic field lines, but another opportunity to manipulate energetic systems within the Earth has to do with the ionosphere itself. And imagine that ionosphere is a bubble around the Earth, several hundred miles thick, again starting about 30 miles off the Earth's surface. Now, that's a highly charged area, a tremendous amount of energy potential there. In fact, some will remember a number of years ago, there was a shuttle experiment where they drug a tether, a dangling wire through the ionosphere to see what would happen. And energy was picked up as it moved, because when you move something, a conductor through an electric field that's as charged as the ionosphere, it actually begins to move current, which it did. It shunted that current straight into the shuttle and almost blew it out of the sky. Now, the thing that came out of that didn't get widely talked about was the amount of energy produced could be useful, for instance, for keeping a low orbiting space platform in orbit around the planet, being able to charge it up by just tapping the energy by the fact that it's orbiting the planet and moving through the ionosphere would be one way to charge up these kinds of space-based platforms, whether they were for weapon systems or running low orbiting satellites. Basically moving energy into space in normal, like shuttle payloads, is prohibitively expensive, very difficult to pull off to any great degree. But if you could create an energy source sufficient to run these kinds of systems, then you eliminate all kinds of logistical problems, and you're able to keep these things aloft for great deals of time. Part of the HARP idea was if you could focus radio frequency energy, you could even concentrate it and send energy directly to these same kind of low orbiting space platforms, as an example. One of the other thoughts with HARP systems are the actual heating of the ionosphere. And when it's heated, because this energy is concentrated, what happens is the ionosphere then lifts up, moves out several hundred kilometers. Now imagine if you're a satellite drifting through space where there's no atmosphere, and all of a sudden you hit a column of atmosphere. What will happen is it creates friction, and that friction causes that satellite to burn up, and all of a sudden you got a satellite down. When you turn the instrument off, everything goes back to normal, and you have plausible deniability on a satellite going down because nobody knows this kind of technology generally exists. Now, the other place you can use it in that same application, imagine that column going out several hundred miles into space from its normal atmospheric level way down here. Now you got an incoming comet or asteroid coming in from outer space at a tremendous velocity. Now normally those objects, when they hit our atmosphere, they again encounter tremendous friction, they burn up, and most objects dissipate before they ever hit the surface. But big objects, the kinds of objects people are worried about, if you could, say, go from 30 miles of atmosphere to 200 miles of atmosphere, almost 7 times as much distance, and project a trajectory downward, what you're able to do in that instance